Hi guys, this is Dennis. This is Array101 part 2. So we left off saying that we were going to create that or change that program from a bunch of variables into an array. When you create an array, you need a size, which is a constant. In this case, 100. Within main, you need the effective size, and that's going to be a variable. And finally, this is the syntax to create an array. Data type, name of array, square bracket, a constant such as size, closing square bracket, the assignment operator, and this is optional. Well, everything from the assignment operator, including the assignment operator, is optional up to the semicolon. This would default all the values into this array to zeros. The program will move up and down the array with a for loop. You can use the other loops. They work too, but most programmers will use a for loop. Example of a program, again, my header, my preprocessor directives. Here's where I declare the size as a constant. I declare the size as a constant. Here's my effective size. Some people don't like the word effective size. It's a little lengthy. You might choose to call it the E size. I've seen that. Or some people call it counter. Here's an array just called simply my array. It's of type int, and it has 17 or size elements. All of the elements in the array are defaulted to 0. Notice I can do something like this. And if I did that, the first element in the array would have a 2, the second would have a 3, the fourth or the third would have a 4, and all the remaining elements would be zeroed out. So if I initialize the first element and nothing else, all the rest of the elements are zeroed out. Wherever I stop initializing, I will get zeros. If I don't initialize, the array will have junk. Here's what we're going to call a loop control variable. A loop control variable is where we use our single letter variables. Here's my for loop. As I said in the slide, we traverse through an array with a for loop, and this for loop would be getting those, in this case, 17, 20 values. Enter value 1 of 17, scan it. 2 of 17, scan it. Notice now when we scan into the array, just like any scanf, because an array is nothing more than a group of variables, scanf, scan for an integer, stored in the address of the first subscript or the 0th element. I'll let you see this run. Here's the prompt, enter value 1 of 17, and I can continue to do this 17 times because I'm in a loop. Notice the code behind me, very short, just one single variable, the array. Now, the next thing that I can do is I can change this size to kind of anything I want. Say I don't want 5 or 17 variables, I want 50,000 variables. Boom. Enter 1 of 50,000. I'm not going to sit here and type 50,000 times. Maybe this would be something randomly populated, but again, I can go all the way up to max int and my size, and my code is still going to look just this simple. So this loop will loop size times. So as we said, arrays are used to store multiple values. Arrays are used to do math, so I can put values in the array, and typically I'm going to do some type of math, and that would be any type of math. I can also store words or characters in an array, and then arrays are used to search to see if a character or word or value is inside of the array, and then arrays are also used to take these values and sort them. The program that I showed a second ago, here's the size, here's the effective size, here's an array declaration. Integer called my array has 100,000 elements or size elements. Elements sub 0, sub 1, sub 2, and sub 3. All the rest have zeros in them. A few facts about an array. The effective E size or the effective size. The E size variable represents two things, not one. The effective size or the E size is the number of elements in the array that are occupied. So the effective size tells me how many things I have placed into the array. And the effective size also tells me the location where the next element is going to be occupied or where I'm going to put the next thing. How many I placed and the subscript or index of where the next thing goes. Think about this, it's an important observation. As I said, each element in an array will be identified by the array's subscript or index. And just to let you know, most people use index, it's more popular. So indexes are subscript. Here would be a diagram of an array. It's not how they really look in RAM, but let's assume I have an array called grades. It has 18 elements starting from 0 to 17. The index begins with 0 and ends with size, which would be 18 minus 1. Inside of an array, that's where the values are stored. Values are stored. They're stored within these elements. So for example, I could put whatever numbers I want in here. The 7th index equals 78.8. So here's a little more information. Here's my size, which would equal 18. If the size equaled 18, the effective size is 17 in this particular case. The effective size is not 17. That's a typo, so I crossed it out kind of. The effective size is actually 18. So the size and the effective size will equal each other when the array is completely full. So this array is completely full, no space for anything else. At array sub 1, the value 7.6 exists. At grades sub 17, there's a 10.10. Notice the size equals 18, so there are 18 elements, but the effective size or the indexes don't go from 1 to 18, they go from 0 to 17. So the indexes move from 0 to size minus 1. There is no grades sub size or 18. There is no grade size sub size or 18 because that's out of bounds. That's down here. You're outside your scope of your array, and that would be bad. That would be bad. I'm nearing the 10-minute mark, so I'm just going to end this video, and I guess I'll have to be creating a part 3. See you in the next video.